All right, welcome back, folks, to another video on foundation on college algebra. My apologies. It's early morning here. In our previous video, we talked and we began to talk about ellipses, some important features of ellipses, and then we saw the first type of problem that we should be able to solve pertaining to ellipses, which is given the equation for an ellipse, you should be able to identify key features like the center, the vertices, the foci, all those kinds of things. In this video, we're going to talk about the other types of problems that you should be able to solve pertaining to ellipses. So this next type of problem, we're sort of almost going to go in the opposite way. If you're only told about the key features of an ellipse, like the foci, the vertices, the center, you should be able to write the equation for the ellipse that has those particular properties. As I said, it's early morning. So here's our first sample. We're going to find the equation for the ellipse that has vertices at -4, 0, and 4, 0, and the foci are at -3, 0, and 3, 0. When you have this type of problem and you have to come up with the actual equation for the ellipse given some of its key features, in general I would recommend that you give a little sketch first. So I'm just going to do a quick sketch here. It doesn't have to be a super detailed sketch, but -4, 0, and 4, 0. Those are the vertices, and then the foci, trying to keep it somewhat to scale here, are those 2 points right there. Now, the reason that we give this little plot is just so we can get our visual combined with the other things that we talked about in the previous video, and we can start to shape what this equation is going to look like. We know that the major axis is the line segment that has the vertices as its endpoints. This major axis is going to be horizontal, so we know that the equation for an ellipse that has a horizontal major axis, it's going to look something like this here. X minus h squared over a squared plus y minus k squared over b squared is going to equal 1. The other thing we can easily find out here is the center. The center is simply the midpoint of our two vertices. Well, if we look at the midpoint between -4, 0 and 4, 0, it's a really quick calculation going all the way back to the, going all the way back to the beginning of this course. It's easy to see that the midpoint is simply the origin. It's the point 0, 0. So that's the center, 0, 0. And we know that the center has the form h comma k. So h and k are both 0 here, 0, 0. I can make those substitutions into my equation, and I can start to get some specific information pertaining to this particular problem into my equation here. So I know that my equation is going to look something like this. X minus 0 squared, or we just put x squared, over something, plus y minus 0 squared, or y squared, over something, is going to equal 1. The question is, we have to figure out what are these things on the bottom. What's my a squared and what's my b squared? We know the a squared, which is our larger number, is going to go underneath the x's the b squared, that's going to be smaller. That's going underneath the y's. Now, how do we figure out what the a and the b are? Well, we're again going to go back to the vertices here of negative 4, 0, and 4, 0. If we look at an ellipse that has a horizontal major axis, the general form for the ordered pairs that are our vertices are h plus or minus a, comma k. Now, we know that h and k are both 0. We found that from our center. So the vertices are of the form 0 plus or minus a, comma 0. And these things have to equal plus or minus 4, comma 0, because that's where our vertices are happening at. We have one vertex at minus 4, comma 0, and then we have another one at plus 4, comma 0. So just doing some simple comparisons here, comparing 0 plus or minus a to plus or minus 4, we see that a has to be 4. That's the only way that these two things can be equal, is if these first coordinates listed are the same, and then comparing plus or minus a to plus or minus 4, a has to be 4. So I can take that a value, and I can square it, and I can put it underneath the x term in the equation for my ellipse. So 4 squared is 16. Okay, we just need to find our b squared value now. So one last thing that we have to figure out. So how do we figure this thing out? Okay, to figure out our b value, we are going to work with the general formula for the foci of the ellipse. If you have a horizontal major axis, the foci is h plus or minus this thing here, and that thing is called c. So it's h plus or minus c, comma k. All right, let's write that. H plus or minus c, comma k. And our foci occur at negative 3, 0, comma 3, 0. So that is to say, they occur at plus or minus 3, comma 0. So again, comparing these two things, we know that h is 0. So we have 0 plus or minus c, and then k is 0 as well. So from this, just like we did with our vertices, we can figure out that c is going to equal 3. Now, we know from our previous video that c squared is equal to a squared minus b squared. I know a, I know c now, I can figure out what b is. So, c squared equals a squared minus b squared implies that 3 squared, or 9, is going to equal a squared, 4 squared, or 16, minus b squared. Well, I want to get b all by itself when this is all said and done, so I need to get the b term all by itself on one side. I can do that by subtracting the 16 from both sides. And that gets me negative 7 equals minus b squared. I can then divide both sides by negative 1. to give me b squared is equal to 7. And then lastly, I take the square root of both sides. So I get b is equal to the square root of 7. So that's our b value. That's the other missing piece that we have to substitute into our equation here. Now, I didn't even have to figure out the actual b value because in the equation, we're substituting in b squared. So I could have just stopped right here and said, okay, that 7 is is all I need. That's what goes there. But if you wanted the b value, that's what it would be. So here is the equation for this particular ellipse. X squared over 16 plus y squared over 7 is equal to 1. Moving on to our next problem, a little bit more complicated, a little bit more work. We're going to do the same thing. We're going to find the equation for the ellipse, but this time the vertices are at 2, 6 and 2, -4, and the foci are at 2, 7 halves and 2, -3 halves. Actually, guys, we're going to do a small change to our foci. We are going to have our foci be at 2, 3 and 2, -1. We're going to work with some significantly nicer values here. So again, we're going to start off the same way. Let's get some kind of visual of our vertices and of our foci here. So again, it doesn't have to be a super detailed plot here, but just something fairly rough to show our vertices. There's 2, 6. Here is 2, -4. And then we have our foci at 2, 3 and 2, -1. So trying to keep to some kind of scale here. I'll label F for foci. So here we can clearly see that the major axis, the line segment that connects our vertices, is going to be vertical. So now we're working with something that looks like this. We're going to have the larger number underneath the y's, not underneath the x's. So we're going to just put a separate little space here for the equation that we're eventually going to have. First thing we can easily do is we can easily find the coordinates of our center. The center is, again, just the midpoint of your two vertices. So if you take the midpoint of 2, 6 and 2, -4, you are going to get 2, 1. And we can take this h value and the k value, because that's our center, h, k, and I can substitute those into the equation for my ellipse. So it's going to be x -2 squared over something plus y -1 squared over something is equal to 1. Now we need to figure out that a value and the b value here. Well, to figure out our a value, we are again going to appeal to the general formula for the vertices. But when you have a vertical major axis, it's going to be h, k plus or minus a. So looking at our vertices, Again, our h value here is 2, and our k value here is 1. So it's going to be 2 comma 1 plus or minus a, and this has to equal, well, we can have 2 comma 1 plus a and 2 comma 1 minus a. And these things have to equal 2 comma 6 and 2 comma negative 4. Really, all that we are saying here with this general formula here for the vertices is how much are we, or how far off are we from the center with each of our vertices. And since the major axis is vertical, we're going to vary from the center by some quantity in the y coordinate. So how far are we going up from the center to hit this vertex or down from the center to hit this vertex? That's really all that's happening here. But if you tried to do this looking at the actual coordinates of your vertices here, this is how you would set it up. But you may find it easier overall to think, okay, my a value really at its core is just what is the distance or what is the length from the center to either of your vertices. And if you think of it that way, just the straight line distance from here to here or from here to here, that's pretty nice to figure out. You're going to find that a is equal to 5. So that is pretty nice. That's a nice little way to figure out what one of your values is. Specifically your a value that is associated with your major axis. So again, because we have a vertical major axis, the a squared is going to go underneath the y term. So 5 squared or 25. Now the foci, and we're going to do a similar kind of thing as we did with our vertices. We're going to first set it up using the actual points here, and then we'll sort of look at, okay, what is the missing piece that we need in terms of looking at the graph here. So the formula for the foci, if we have a major vertical axis, is h comma k plus or minus c. Again, working with our h value of 2 and our k value of 1, that gives us 2 comma 1 plus or minus c. And that gives us 2 ordered pairs, 2 comma 1 plus c and 2 comma 1 minus c. And we know that our two foci are 2 comma 3 and 2 comma negative 1. So we can do some basic comparisons and we can figure out what our C value is, but really just by looking at the graph and the visual that we have here, you'll probably find it a lot easier to think of our C value in this way. The C value here is really just what is the distance from the center points to either of your two foci. How far is this, or what is this length from here to here, or this length from here to here? They should always be the same length. So the question is just what is that length? What is that distance? Well, to go from 2 comma 1 to 2 comma 3, again, there's only a change in the y, y coordinate, and that change that we have is 2. Now, it doesn't matter whether we had a horizontal major axis or a vertical major axis. Your C value here that we have showing up in our foci, the C value is just what is the distance from your center to either of your two foci. The A value is simply what is the distance from the center to either of your two vertices. So we have our A value that's known. We just found our C value. Let's see if we can come up with our B value. Just like the previous problem, we're going to use that C squared equals A squared minus B squared thing, and we're going to see what we come up with. So C squared, 4, is equal to A squared, 25, minus B squared. Subtract the 25 from both sides. Negative 21 is equal to minus B squared. Divide both sides by the negative 1. B squared is equal to 21. And then take the square root. B is equal to the square root of 21. Now, once again, I didn't even have to come up with the actual value of B. I could have just stopped at the B squared, because the B squared is what's actually getting plugged into our equation. But it doesn't hurt. Find the B value just so you know for your own sake. And there we go, guys. That is the equation for this particular ellipse. X minus 2 squared over 21 plus y minus 1 squared over 25 is equal to 1. So those were our two sample problems. Finding the equation for an ellipse given some key pieces of information, the vertices and the foci. Those are the only two things that you really need. You can determine the center from the vertices, and then you have all the information that you need. There's one last little calculation that I want to talk about in this video to wrap it up. Ellipses have this thing known as eccentricity. The eccentricity of an ellipse is given by the simple quotient of E is equal to C over A. And if you want to put things in terms of A squareds or in terms of A and B, C is the square root of A squared minus B squared. So C over A is the square root of A squared minus B squared, all that over A. And note that the eccentricity of an ellipse is always going to be a number strictly between 0 and 1. If you're getting something less than 0 or you're getting something greater than 1, then that means you done goofed somewhere. So just as one quick sample, a very quick sample, find the eccentricity of the ellipse in the previous sample problem that we did. Well, E is equal to C over A. When we went through our previous sample problem, we figured out what our C value and what our A value were. C was 2, A was 5, so that means that C over A is equal to 2 over 5, or 0.4. This is also very easy and straightforward to calculate if you're just given the equation of your ellipse like we did in the previous video. Simply do A squared minus B squared. That gets you some number. Take the square root of that number. Then take that square root that you just found and divide that by your A value. And there is your eccentricity. So the calculation for the eccentricity, nothing crazy, very basic, very straightforward. So guys, this concludes our video on ellipses and knowing the types of problems that you should be able to solve pertaining to ellipses. If you have any questions or comments, please be sure to reach out to me, guys. Texts, emails, voicemails, telegrams, signs flying on the backs of planes in the sky, whatever you need to do. Until the next video, take it easy.